Okay. Now I have this wire to worry about. All right, so those are three categories. So let's jump into the first one, which is orchestration services. So let's start with AWS because it's popular, it's dominant. What is CloudFormation? They basically categorize it as a service for businesses, for developers. Lets you create a collection of machines in an easy way. Let's leave easy off. Creates a collection of machines and resources. So AWS is made up of many, many different tools and product names. It lets you create a collection of those together in a predictable fashion. So there's ordering, there's dependencies, there's waiting, all of that's kind of built into CloudFormation. CloudFormation is built in two concepts, one of which is a template. And so in CloudFormation, it's a JSON template. It describes the thing you're doing. So you have resources in the template, like load balancer. Load balancer is configured this way with parameters. That's your template. The templates build into a logical grouping called a stack. And so a stack may be like my infrastructure. And so your infrastructure may have templates for like load balancer instances, databases, other things. Those kind of roll up into the stack. You can have them, the source for your templates be their local files. So when you run it, you're like, hey, cloud, do something from file. Or from an S3, which is an object storage on the internet, as a URL. Also, the nice thing about having all this kind of together and rolled up versus like different tasks just kind of firing off, like build web server, build load balancer, connect web server and load balancer, is you get the notion of the automatic rollback. So that whole thing is sent as a single object, a single unit that it's going to perform. And if at any point in that task, like, hey, I don't have any more elastic IPs to associate, or hey, the AMI, the image I told you to build a machine from isn't valid, it takes that whole unit that I said, go build my infrastructure, and it can roll the whole thing back. So you're not left with databases without web servers connect to it and load balancers without instances behind them, and now you're doing a different cleanup step to go back and clean all that up. So the failing in the middle of all of this is kind of a hard problem to solve for a lot of tooling. AWS supports many things that you can, the CloudFormation, supports many things that you can manage. Their resources in the template, so you can bring these in if you want to manage. EC2 is like your compute resources, so they're like the VMs on Amazon. Auto scaling is a pooling around machines that you want to build up or down, or different things, not just machines. You have your load balancers, you have your messaging queues, your object storage, your databases, your identities, so you can control things like group ownership or group permissions and roles and users and things like that. So here's an example of a JSON, a snippet. These can be very long if you're describing all the things you're doing. A snippet of what we want to do. So to just break this out in smaller pieces, make it a little easier to digest, we have a load balancer. And it's a elastic load balancer. So we describe in the template what is this thing we're describing. So first is the resource name and then the type, and then it's going to have properties. And the properties are things like where am I putting it and what's going to be behind it. And these are, you can actually have them linked to each other, like, hey, that thing I just built, now use that as what you're going to put behind the load balancer. Configuration for the thing that you're deploying. So like, what port are you going to listen to, and what port are you sending traffic to behind the load balancer? So not only am I listening on port 80 when traffic comes to me, but where am I sending that traffic once it goes to the instances that are behind me? And what am I supporting? Is it, what protocol am I actually talking? And then you build things in like thresholds for healthy. When things fail, how long do you let them succeed before you bring them back in? How long do you make those checks? Like 30 seconds in, at 3 failures, it could drop out. So, and where are you looking for that check? And this is just saying basically the root of that endpoint. So all the things that you would normally define for like a simple load balancer. I'm going to route traffic. I'm going to look at this place. If it ever fails, I'm going to stop routing traffic to it, and I'm going to put some machines behind it. Another example is for user creation. So this is creating a user called myUser with a password that we just put up on the screen. Route 53, so DNS in AWS. So this is an example of a record I'm creating, which is a weighted round robin record, which means I'm not going to route traffic like you get one, you get one, you get one, you get one. There's actually a weight to it. So you'll see the weights defined in the objects I'm defining here. So this is mysite.example.com. It's a CNAME record. It has a TTL. So if you think of like a web form, these are all the things you're filling in on that form already, but just kind of codified, version controlled, and maintained that you can share it with other people. So your documentation is not, I went to a website and pushed these buttons and typed these things in. It's like, here's what I did. And that's easy to share. It's easy to version. And if I run this again with different values, I'm not worrying about what's set currently. It's going to change it to the state I want it to be. So I have two records, example EC2 and example EC2 larger. They're both records that will round robin for in example.com, the record mysite.example.com. And this one has a weight of 4, and this one has a weight of 6. So it's just send more of my information to the larger machine and less of it to the smaller machine. The next one, so that AWS was specifically for Amazon. It is Amazon's product for Amazon platform. Because Amazon is so large, I'll show you some of the other platforms actually just accept CloudFormation templates into their systems as well. So OpenStack Heat, OpenStack has many different projects. They have a grouping of one currently called the orchestration program, but inside the orchestration program there is the OpenStack Heat project, and that is a system templating orchestration system. It's an engine. One notice there is not every OpenStack implementation will have OpenStack Heat. It is actually like a module you put on your infrastructure. But if you have OpenStack and you have OpenStack Heat, you can define templates that you feed Heat and make it do things. It does support two different formats. The JSON format is the CloudFormation, and the YAML format is what's called HOT, which is a Heat orchestration template. And that tells it how to do things on OpenStack. But it actually has the same structure, template, and stack. And the native template format, which they're moving to, which is the HOT format, actually has less, I believe at this current point, has less functionality than their support for the CloudFormation format. So you can do things like interact with compute instances, network ports or routes or IPs, volumes. So attach a larger disk to this instance, object storage, like creating buckets or containers, and metrics and information. And the last one's kind of key. Without the information about these platforms, so Ceilometer actually buys you the ability to do things like auto-scaling. So because it can talk to the thing that has information about your cloud, you can use that information as triggers for, like, I need more machines. If CPU's high, I need more machines that can handle the load. So this is the YAML version, like I said, hot. You have your template version because, like APIs, things version. Description, just because you're trying to be nice to people you work with. You define parameters. So one thing about this, as you're building these out, you can actually make these like interfaces, just like you do in configuration management where you have like cookbooks, and cookbooks have attributes, but you have default attributes. And the attributes are actually the interface to the cookbooks. These templates, you could build in parameters, and the parameters are the interfaces for how people would use it. So if you had something different that you need to roll, like, hey, we need you to pass billing code, that you can have expected values, you can have patterns around how you're going to accept that, and what you're going to display to the person if that pattern doesn't ever match. If you're expecting a billing code with only a number and they give you a value, like a alphanumeric or an alpha character, then what do you tell people? That's all just like things you could describe. Some of this where you describe your parameters. And there's labels and descriptions and types. So these have type string and descriptions associated with it. So this one here sets up this is a very simple single instance with parameters and output. So we have parameters, resources, outputs. This is an instance we're calling my instance. It's going to use type, just like we did in CloudFormation, of Nova. Nova is a compute project for OpenStack, Nova server. We pass it a key name, so we could do things like we do have parameters. So when someone calls this, they need to pass key name and instance type, and those parameters, key name, become the parameter that we're feeding to the template. whereas things like image is just a string that we passed in. So if everyone's always going to use the same image, which we don't do because things like Heartbleed and Poodle and Ghost and everything else happens, we have to update the images. You could define things, but you also have parameters you could pass in as well. And that's the YAML. And then this one has output. When I do this thing, what should I tell the person I did? And I'll just give them my instance and my address. So go build server, and it's like I did, name of machine, and IP address of what I built. Here's a different one for, like I said, we could do things called auto-scale, and this is a load balancer as well. This is going to be broken up across multiple slides. This is a Rackspace example. So they have a cloud load balancer to port 22 of the instances. And so this one actually has a webhook that you would call. So you may have some automation that says, call this webhook, and this would either scale it up or down. So it's based on an endpoint that's like a trigger. It's like a switch. So you go in there and you're like, up, I need more, I need more, I need less, I need less. And so we start off with the parameters again. So you're going to have a key name, a flavor, and an image. And then you're going to have your resources. And this one's the my load balancer of type load balancer. And you'll see that the type is actually Rackspace and not OpenStack Nova. You could have different providers have different types. But Rackspace is an OpenStack platform. Protocol, TCP, port 22. And this is the load balancer part. The next part is the group, which is that auto-scaling group. So here's auto-scale group. And then we have our properties again, group configuration. So these are some default values we're setting. Launch configuration with arguments. And our load balancers as, so this is a good example. I told it to create a load balancer. That load balancer, when it creates, most things when you make a call, it's going to pass you back like an ID. So it's like, I just made load balancer and like some shell hash. You can say, now bring that load balancer in as the ID for the next thing I'm doing, which is an auto-scaling group. So you can perform actions and then use those actions as input for the next action in your task. These are like the functions for what I'm going to be doing when I want to scale up and down. This is my add one and decrease one policy. And the change here, we do a change +1 and change -1. And these are the hooks. Remember I said there's like that switch that we're going to do? And some funny metadata just for an example of is cool. But you have names, you have the policy that you're calling. So you describe the policy, and the hook is then using that policy. And the output of what we're doing, so you say, go make this auto-scaling thing that's going to have these triggers, and it says, I did that. And here's where you're going to go if you want to scale up, and here's where you're going to go when you want to scale down, and this is the public address of that load balancer I created for you. So the next one is OpenStack is for OpenStack. It supports CloudFormation. Terraform is, go ahead. JSON would, the first example I showed you, Amazon with the CloudFormation, you could take that template and go to Heat and give them that template. And so there's a correct. If you're doing it in JSON, I believe you're doing it in the CloudFormation format, though. I'll finish the orchestration services, and we'll stop, and I'll give you guys a chance to kind of checkpoint there. Terraform is, if you guys have heard of HashiCorp, of Vagrant and Consul and Packer and other cool tools, they're trying to make a abstraction away from this, because there is the, I take my CloudFormation templates to OpenStack or to Amazon, but if I go to Google Compute Engine, there's a different solution. So they're trying to get away from this vendor lock-in around orchestration on the cloud. So Terraform, in its end goal, succeeds at making an abstraction layer that you talk in a standard DSL, and that just like you do for config management, and that then results in automation that happens on your cloud. So it's claimed to be a flexible abstraction of resources and providers. So here's an example. This is for AWS. I believe OpenStack support's coming real soon. Provider, this is where you kind of would have the same definition down here, but you would swap out provider. That's kind of the end result that you're hoping for, is that you have something abstracted enough that the way that you're just simply pointing it to a different location or a different type of cloud. So this provider would need a region. Different cloud providers may need different parameters, like what is your tenant ID or something like that. But again, it's the same kind of format. You have a resource, load balancer, we're going to call it web. And then we have Terraform load balancer we're describing in this availability zone. There's a lot of constraints around, like, I can't load balance to an instance in a different zone kind of thing. We have our port. Again, we're configuring the load balancer. What's the port? Where is the load balancer listening? Where is the instance behind it listening? And what protocol are we talking? And what instance are we actually routing traffic to? And then we actually build the instance. We have a default user and a key. Most times when you spin up a cloud instance, you pass in a key pair, and you don't get like a username and password. You actually just say this user at this IP address, and your public key is waiting for you on the other side. And so this is the parameter we're passing to this. And so the idea is this is a little more generalized abstraction away from things that should be more portable, I guess, than what you're doing. And this is just another thing with security groups. And then we'll kind of get into, like, later on Chef and Puppet. But there's actually this notion of provisioner. So machine's up, what do I do now? And you could just do like a script. You could say do these things, or you could say run Chef, or you could say run Puppet, or you could say install the Chef server so I can run Chef on my next one. The idea here is I'm going to spin something up in a general way and then hand it off to something else that does that tool. If it's just scripts, cool. If it actually is config management, Terraform's not trying to take over that. It's kind of trying to just let that be pluggable. So any questions before I go into libraries?
How up to date is Terraform on the capabilities of AWS? Do they keep lockstep whenever AWS has new features with Terraform?
So they actually, from what I heard, they actually have, when they run their tests, they look at what AWS has at the point for like API endpoints, and they say like those are different. And so CloudFormation from Amazon is actually a different project than a different team than Amazon. So there's some, even when Amazon has a new feature, CloudFormation may not have it yet. With the speed that Terraform moves, they may actually get to a point in the future where they can have a feature in Terraform before CloudFormation has a feature in CloudFormation. So I do know from talking with developers from HashiCorp that that's their goal, is to, like, new feature came out, Terraform supports it. So that's where they're going with that. Any questions before we go into libraries? All right. So if your shop likes Ruby, there's Fog. And Fog is a Ruby, it's not the system provisioning Fog you may have heard about. This is a Fog/Fog. It's a Ruby library. And the idea is it focuses on cross-service compatibility. Now I'll show you in the next slide what it supports. Actually, I had to make it smaller. It supports like 45 different cloud providers. But here's an example between Rackspace and Google, how I define a connection with the parameters that connection needs. So Fog compute new, pass it a provider. Because I know it's Rackspace, it's going to have a Rackspace username and a Rackspace API key, which are the things I need to authenticate to Rackspace. Whereas in Google, I have a provider, a project, a client email, and a key location. So once I have the initial connection defined, I have the authorization URL, which is something else you're going to need. But I do connection.servers.bootstrap and connection.servers.bootstrap. So my go build server is actually the same step on both once I have the parameters set up and lined up. So Fog is, if you use a lot of tools use Fog. So if you go out and use like Foreman for Puppet, behind the scenes you're using Fog calls. If you use like Chef provisioning, you're using Fog calls. So a lot of the tools that you use are like, hey, I'm an abstraction away from all your different places, and you could build stuff through me. A lot of times they're using Fog as the back end for that, because there is, because of things like this. So Fog supports AWS, DreamHost, Google, HP. There's like 5 between every one of these bullets of other ones, but I didn't want to like scroll on a slide. So even vSphere and like Overt, there was like libvirt. So all kinds of things. Write it once, and usually it's like create .servers, and you could pass it, but it's only servers. Um, and I don't know if I actually cover that well. Fog supports all kinds of things. So for a while there, I was using HP Cloud, and HP released their own Fog library because nothing, like it wasn't OpenStack and it wasn't anything else. Like it was kind of, but different. Um, so HP released their own Fog, so I could just plug in, like, hey, HP wants a region, so I could, add that as my parameter to my connection, and the rest of the things that my tool was doing around building servers or requesting interfaces or attaching IP addresses were almost the same code. It was just I changed out the initial connection. So Fog also has this notion of like a mock mode. So if I don't have an endpoint and an account to go hit, there is some resources that support mocking. So I'm like, hey, I'm going to do some, I don't have this endpoint, but pretend like you do. So you could say I have this storage endpoint and my key is bogus and my ID is bogus and my provider is AWS. And this kind of would show you what a real one looks like, which is actually similar, but those keys would be valid if I unmocked it. But the idea is I could hop in there and do things like create container, and then I could say like list container. So I could kind of interact with the tooling without actually doing that on infrastructure. And that was one of the things with Fog that seemed kind of cool. Photo is great for if Python is your experience, and this is kind of like an interactive use of Bodo. This is like just I fired up Python and just started typing in an interactive mode. But it is right now for web services, for Amazon Web Services. But import Bodo, import time for one of the things they were doing. And you have a Bodo.connect. And this was like S3, create bucket, and set contents for string, and then wait for 2 seconds, and then get contents. So it's like I'm going to make a thing, I'm going to set some contents in there, let me wait, I'm going to get those contents out. So Bodo is a way, I think it has like really deep AWS service mapping as far as what it supports, but it's Python interface to doing things on Amazon. Okay. Maybe they do. I still know that like their header is still like the AWS Python interface, but and that's at the end. A lot of this is actually changing. So like what's true this year is actually like completely false next year. A lot of this is adding support for many things. So. Yeah, nice. So they're like feature parity with new products that come out. Yeah. Yeah. So and what you might find is like a year from now, like Bodo supports OpenStack or like Rackspace is OpenStack. Like all these tools are growing in what they're supporting and what they're allowing you to do, to where like Bodo may be like the Python answer, and Ruby may be like or Fog may be the Ruby answer, and then you may have like a tool that abstracts that all away and gives you a nice web GUI. So these tools are changing. So and I'll kind of touch on that at the end. And then you have configuration management. And fill in any of this. Actually, before I move on, any questions or comments or corrections? There is a Go SDK that was just released last week for AWS. But again, that's at the SDK level. I think and there is the Amazon SDK, and there's all these SDKs for every platform. More of these are targeting like a layer above that. Whereas like Bodo may call directly to the APIs versus using the SDKs that call the APIs. All right, so configuration management. So the main, does configuration management work for you and doing your cloud provisioning? I would say it depends. Like, what does your infrastructure look like? What do you need it to do? If you're just like, I need to spin up 5 machines to put a load balancer behind it, probably can make configuration management work. What is your platform? If you're like, hey, I'm over here running the Verizon cloud, and I want to automate that, like maybe config management works for you. And then we'll look at a few of just what we can do. So if we said I want to use Chef and I want to talk to AWS, I went out and there's a Chef cookbook, Chef AWS cookbook, and it does some things. One of the ones that's not here, it's kind of like not kind of supported, but like feature functionality there is Route 53. But you can do things like create volumes, create raids, manage elastic IPs, which are like pluggable IPs that move between instances, set up load balancers. There's other like interactive tools like Knife and Knife EC2 that lets you actually like go build this machine right now. And people do things like script around Knife, for instance. So here's some snippets. This is actually pretty easy to consume and digest. You have a resource, an AWS EBS volume called DB EBS volume, and you just pass the parameters you need. What's the size? What's the access key and the secret access key? And the device and the action. So create that and attach it. You have the creation of an elastic IP from something I'm pulling from my organization. You can create that as well, and then associate it. And then, like, if you want to do a load balancer, same kind of thing. So most of these are abstracting away the parameters you would feed to an API in a way that's consistent with the other tooling you're using. So if you're doing things like deploy applications, and you know like Chef DSL and how you work in Chef, the point of this is it brings that knowledge of what you already know and how to use that tool into a realm where you can do it for your infrastructure. There's also a new project they started doing. It was at one point called Chef Metal. I believe its current name is Chef Provisioning. It's still really early on. Similar to Terraform, where we're just hoping one day we just change out Chef Driver to our cloud platform, and we can now do things. The big thing about Chef is you use resources, and Chef Provisioning brings in the notion of a machine resource. So no longer are you doing things like file and service and package and user, which are all resources of things you manage in configuration management, but now you have the notion of a machine resource. And so this brings in, I'm going to make a machine called Mario, give it this recipe, which is a Chef notion of like what I'm going to do on that machine, which is Postgres and my database, and you give it a tag. And then you have some Ruby up here where you say number of web servers is 1. I can change it to like 3 or 5. And for the number of those, make Luigi's, which are Apache web servers running my app. So in line with where I'm going to say deploy Nginx and my static website, you could say, but first build a machine. And that kind of puts all your full stack kind of collapsed into a single view where you could version that a lot. It's no longer like infrastructure code, application deployment code, and your actual application code. You can kind of start merging some of those together to where it's all versioned as one unit, like my stack or whatever. And that's the goal of this. It's, I believe currently it supports AWS EC2. So I don't think you're going to get things like managing buckets on S3 yet, but they're trying to bring in the notion of how do I go to a new cloud and set up my Chef server before I have Chef. And so it's actually running this locally on your machine and then connecting out. And I believe it like connects out to the instance your provision or the spies up a Chef server, and that connects out to like your APIs you're talking to. So it's actually doing it like through Chef, but without needing a Chef server. It runs it in Chef 0, I believe. I don't think that. I don't believe. I may be wrong. I don't think Knife is going directly through Chef, and they're using things like searches to then feed in. Whereas the machine resource would like spin up an in-memory Chef server where you can do like attribute resolution and everything from it, and then use that to apply it. And so you get things like the idempotence and everything, whereas Knife is more of like an interactive one-off, go do this thing. And that, yeah, so a lot of these things like there's M Collective, there's Knife, there's all these interactive tools. Ansible has, Ansible runs agentless. So a lot of these can be like one-off fired out there and go build, machines 1 through 5 now. But this is more, and then maybe you put that in a script, and you're like, this was the Knife OpenStack server create, machine 1, machine 2, and that's a script you ran, like a bash script, and then you version that and put that in your repository. Like that's a good first step. Is like I did these things, which wasn't this interactive, like I was on a website doing things, but I actually ran codes or commands, and that built my infrastructure, and then I captured that and saved that for people to see. That's where most people are at today, and that's like a really good step, because I could just go and say like build cloud.sh SH, and it, serialized, goes through the steps and builds everything up. The idea of using one of these frameworks is that you kind of get the idempotency around it. Like if machine 3 was already built, don't build it again. And so this is kind of going in and like maintaining like a test and repair loop, as the chef community says. But it's like, is machine 3 there? No. Well, it should be, and build it. And is machine 3 there? Yes. Okay. Well, then let's move on. Like, and are all the states of what I want to maintain set to what I want them to be? Are all the parameters correct? Are all the tags correct? And if not, then it's like, okay, well, don't create the machine, but update the tags. And so it's trying to maintain that state that you want it to be, regardless of where it is currently. Ansible, if you go out and look at Ansible AWS, so this is all, the reason config manager is kind of hard to explain is because it depends on your cloud, what your provider, and what you're trying to do. But again, if I take the AWS example, Ansible has modules. A lot of these are in core, so if you went and got Ansible today, you would just have support for these. For things like setting up machines and load balancers and object storage and VPNs and memory caching and DNS. So Ansible's YAML, I think by default, there may be like a JSON mode, I don't know. So EC2 is the module I'm calling, and you just pass your values in of key name and group. And again, it just becomes parameters. But with this one, you're not defining a name in the machine. So you'll see I'm going to pass a key, and it's going to be put in a group. It's going to be this micro instance from this machine. So you're like, hey, build a small machine using CentOS 5. Don't move on until it finishes, but don't sit there and wait forever. And build 5 of them. But put them all in this group, turn on monitoring, and put them in this subnet, and give them a public IP. So this was like, how do you build 5 machines in Ansible on AWS? This was a load balancer example. And so ELB, you'll see the notion of ELB, that's the Elastic Load Balancer in Amazon. And again, like I said, it kind of does that, is that thing there yet? And if it isn't, put it there. But if it is, like, I think in this case, it's making sure it's not there. So the state absent pre-task, and then the post-task, you see state present. So it's making a load balancer with the thing behind it, and if it exists, make it go away and put it back. So I actually went through that pretty quick, but in the end, the answer for what you're going to do for your infrastructure really depends. If you have a simpler infrastructure, you may just go out and be able to, here's my template that I use to build my cloud or my application hosted on my cloud, or all of my applications. But if you start getting really deep with what products you're using and what functionality you're using, and you're not simply just stamping out instances and putting them behind a load balancer, the tooling that you can use may change, because not everything has a level of support for every service you need. For instance, I had an instance where I was stamping out the cloud environments that required object storage for repositories like RPM repositories and Docker images. And the next cloud I built, the easy solution was just to say, hey, object storage, send all your data to this new location. So that required managing a sync replication inside of my object storage. And all of the tools I looked at were like, well, I could create the container, but I can't ever do anything with it. I can't manage sync replications or anything. So if all you need to do was create the new one, if every time you're starting fresh, it was fine. But if I wanted to shoot all my data to the new place by managing the sync replication inside the container, it was broken. So, or it required enhancements to support that. So it depends on what you're doing, and it depends where you're doing it. So if you're out in like Amazon, Rackspace, Google Compute Engine, you'll probably have an easier time of having this community of people developing tools for you. But if you're somewhere like Verizon or HP Cloud, like, you're not going to have that out-of-the-box support for things. And again, you may look at, like, maybe you are on Amazon, and maybe you're trying to do something that's pretty general, but your team's a Ruby team or a Python team. And so there's different tooling that may allow them to be more efficient at what they do without the learning curve of a new language. And the last thing, kind of like what you said, a lot of this is changing to where I think even like a year ago, chef provisioning didn't exist. and the notion of like OpenStack support was completely changing from where it is today. So I think a lot of these tooling, it's kind of in a weird state where it's all kind of alpha and it's all kind of like not supported. But I mean, like Docker's been out for 2 years and it's like the most stable thing we're playing with nowadays. So I think an idea that these different toolings exist is simply the fact of what I was trying to drive home here is there is a Python version and a Ruby version, and there's orchestration tooling around it, and then there's config management that does some things. There's not really like I can do everything you want across all the different places you want to do it at solution today. So kind of keep an eye out for where these tools are now. There may be a new thing that comes up next year, but it's definitely growing and changing, and it's something we've kind of gotten to the place where people are comfortable with automating their application, and they're comfortable with automating their system, and now we're really looking at like now how to do it for everything I manage without like go build one machine, go build the next machine, or I could build all my machines but not the services they depend on. So now we're kind of leveling that up to the entire infrastructure of what we're trying to do. So any questions with that? Okay, thank you very much.